Hello everyone, welcome back to the channel. Today we'll be doing Advent of Code 2025 Day 1. If you guys don't know what Advent of Code is, it's basically a set of programming challenges that runs yearly from December 1st to the 25th. These challenges are great for improving your problem solving skills. I'll be solving Day 1's challenge in Python. As you guys can see, I'm a little late on the days, but regardless of that, let's jump right into Day 1. Alright, Day 1, Secret Entrance. As you guys can see, I already solved this puzzle. So I'm just gonna give a quick summary of this challenge. So, with Advent of Code, guys, there are two parts of a challenge. Part 1, and also if we scroll down, part 2. So what I'm gonna do is summarize part 1 and then jump straight into the solution. So with part 1, guys, simply you are given a dial, which is a starting point, initialized to the value 50. And the goal is to rotate the dial using these sample or example instructions that they give us. L means to rotate the dial a number of places to the left, R means to rotate the dial a number of places to the right. So L68 means to rotate the dial 68 positions to the left, R48 means rotate the dial 48 positions to the right. So when we're performing a left rotation, guys, notice down here it says the dial starts by pointing at 50. We do L68. We're simply saying, hey, subtract 68 from this dial, which is 50, and we would get like negative 18. But how does the dial point at 82? That's because we're of modular arithmetic. So if we scroll up above here, guys, you can see it gives us a hint right here. The dial is a circle. They also give us a range. Left from 0, 1 click makes it point at 99. Similarly, turning the dial right from 99, 1 click makes it point at 0. So look at this, guys. They give us the range above here, 0 through 99, which is below 100. So if we did a left rotation, so L68, 50 minus 68, that would be like negative 18. And if we did a modulus 100 on that, we would get 82. And then if we did a left rotation on this, you can see the dial got updated to 82. So now we're simply subtracting 30 from 82 and we got 52. But we always have to perform modulus 100 on the result so that it remains within the 0 through 99 range that they give us. Now, guys, at the end of each rotation, the goal is actually to check if the dial points at 0. So we count the number of times the dial points at 0. So you can see it points 1, 2, 3 times. So you can see it says the password in this example is 3 because the dial points at 0 a total of 3 times right here. So if we're doing a right rotation, guys, we are simply just adding the value. Like right here, we're doing 52 plus 48. But in order to keep it within the 0 through 99 range, again, we do modulus 100 in order to let it remain within that range. So now that we understand the goal of this challenge, guys, for part 1, let's jump straight into the solution. Alright, guys, so let's start coding part 1's solution. So as you guys can see, I already have the puzzle inputs, the sample.txt and the actual puzzle input. So I'm just gonna clear the screen and I'm just gonna open a solution.py file. So guys, the first thing we'll do is read from the sample input. So let's do with open, and we'll open sample.txt as f, and let's actually create a variable. Let's call it rotations, and we'll create a list, and we'll say rotation in for rotation in f.readLines. So we'll simply be reading each lines within our sample input, and then let's do rotation.strip so that we don't have any new line characters. And let's do a simple test. So we'll just print out our rotations that we read from the sample.txt. And let's test out our code real quick. Alright, so let's do python3 solution.py. And you'll see that we get L68, L30, or 48, and so on and so forth. So guys, one thing we could do, since when we're going to the left, it would be a negative value because we're simply subtracting from the dial, and our 48, for example, means we're basically adding a value to the dial. We could actually just convert these instructions into negative and positive numbers. So let's actually create a function. Let's call it define interpret rotation, and it will take in a rotation as a parameter, and then all we'll do is simply just check if the first character for that particular rotation is a L, then that means we'll simply get the rotation and we'll set it equal to everything else after the L. So we'll do, let's say, 1 colon. So we get everything after the L, and we'll convert it into a integer, and we'll just multiply it by -1 to convert it into a negative value. And then we'll do else rotation equals to int rotation. So that is if we're going to the right, which means we will have a positive value. And then we'll simply just return the rotation. So right where we're stripping the new line character, we'll just call our interpret rotation function. And then if we run our code now, well, we got an error. Oh, I see. Yeah, it should be index 0 for the first character, and we'll check to see if it is equal to capital L. And if we run our code, you'll see that we converted our instructions into negative and positive numbers. So now we can actually try to solve the challenge. So let's start by creating a variable. Let's call it dial, and we'll initialize it to a value of 50. And then we'll say for rotation in rotations, we'll say, let's actually print the dial position initially. So we'll do print dial, and we'll say dial will be equal to our current dial position plus our rotation value modulus 100, because we'll need to keep the dial within the range of 0 through 99 that they gave us up here. And at the end of a rotation, we'll say if the dial is equal to 0, then we'll need to get the password for it. So we'll say password equals to 0 up here. So we'll keep track of the count that the dial is equal to 0. So we'll say password plus equal to 1. At the end, we could just say the password is, and then we could just say comma password. We could actually even print the dial position too. And now, let's run our code and see what we get for the solution. So it says the password is 3 for our sample input. So there we got the same answer as well. Now let's try it on the actual puzzle input that they give us. So we can put puzzle.txt, and now we should get 1026. So there we got the same answer for part 1. And that is the solution for part 1, guys. So let's go into part 2. Alright guys, now to summarize part 2 of this challenge. Now guys, part 2 is similar to part 1, but the twist is that instead of keeping track of the number of times the dial hits 0 at the end of a rotation, like in part 1, we need to keep track of the number of times the dial hits 0 during a rotation or at the end of one. So here's what this really means. Right here, you can see the dial is pointing at 50. And when we rotate it to the left 6 to 8 places, it hits 0 at least once during this rotation, but not after the end of a rotation, because it points at 82 at the end of the rotation. So basically with part 2, all we need to do is keep track of the number of times the dial hits 0 during a rotation and also at the end of a rotation. So if you guys look at this example for part 2, the dial hits 0 1 time, 2 times, 3 times, 4 times, 5 times, and then 6 times. So you can see it says the password for this level would be 6 because the dial hits 0 6 times. So now guys that we understand how part 2 works, let's implement the solution. Alright guys, let's start implementing part 2's solution. So because part 2 is kinda similar to part 1, we could actually modify part 1's solution in order to solve part 2. So I'm just gonna copy part 1's solution, and then we're just gonna modify part 1's solution. So let's think how we could solve part 2. So with part 2 guys, we need to keep track of how many times the dial hits 0 during a rotation and at the end of a rotation. So we could actually do a brute force approach in order to solve this problem guys. So let's see how we'll implement this. So one way we could do this is determine the direction of a rotation. So we could create a variable, we'll call it direction, we'll set it equal to a step value. So let's say if we're going to the left, we'll set the direction equal to -1, meaning we're decreasing the current dial position. And then we'll say if the rotation is less than 0, otherwise we'll do a 1, which means we're going to the right. And now guys, we could actually perform the rotation one step at a time instead of just going straight to the end of the rotation. So we could have a loop right here. We could say like for step in the range of the rotation, But we have to find the absolute value of the rotation, guys, because we want to get the number of places we should rotate to. So we'll find the absolute value of the rotation. And then we'll simply set the dial equal to the dial. But instead of plus rotation, we'll simply pass this direction variable right here. So we move the dial one position at a time. And we could actually, we don't even need to print the dial right here. We could print it at the end of a rotation. And then in here, we could say if the dial is equal to 0, we could actually increment the password by 1. So we don't need that password plus 1 down there. And now, this should give us the password for part 2. So let's see. If we run our solution now, you should see the password is 5923. And that is it for Advent of Code day number 1, guys. I hope you all learned something valuable. Don't forget to hit the like and subscribe button. Stay tuned. Thank you guys for watching, and I'll see you in the next video.